Okay. Okay, I have it. It's on. It's live.
Yeah. Fine. I'm just gonna wait. What? Oh yeah, this is the name. Everyone on YouTube, we're gonna start at 5:30. Is your phone? Oh, bro, I finally bought a water bottle. I can't repair it. Got my Citadel water bottle so I can flex too.
Bruh.
Let's go.
I did for a while. I don't know anything about it. I just played it for like 2 days.
Yeah, what are the rocks really called?
Seriously? Wait, like, is it like music saying?
Yeah.
Basically?
Yeah, but everybody's like really good. So I don't know.
Oh, I mean, I just want to see like what they do. I don't know. I don't even.
Well, I've only gone one time and it's had 2 meetings. I went the first time and it's just too like again. Yeah, you can. But it might not be that fun because everybody's really good.
Yeah, and I'm going off the floor, so.
Yeah, you just bring a controller. Well, it's free on computer.
Yeah, I know.
So yeah, you can just.
I'm just used to like controls out on like a PC.
Yeah, that's what most people use a controller on PC. Yeah, this is what they're like user keyboard. I do, but I'm like a minority.
For shooter games, they don't use controllers.
No.
Like Ordinal uses.
I mean, I tried PC and it was hard. It was so hard.
Yeah.
Like, I was trying to. I'm trying to. I'm literally trying to. I'm joking. Oh, that's why it's so loud. Okay, it's like the east were even student unions.
Right.
Yeah.
There's a club there. There also is like founders. Well, I get the founders building. They only let you use every other computer for the social.
Wait, Lon, does this stream work? Does this stream work?
Yeah, it's definitely a way to like see. Yeah, they just do it so they can get their.
Does it work? Well, I mean, does it- This one? Like YouTube? Hello? I just speak loud. Hello? That works? Hello? All right, we're starting in 5 seconds. 4. And it's 5:30. Okay. Thank you for everyone for coming out. How's everyone's week? Mine's pretty bad. I hate it. Anyway, so thanks for coming out. AIS Workshop on Friday, 5:30. We're gonna be doing introduction to deep learning. You guys ever heard of deep learning, machine learning, or artificial intelligence? We're gonna learn more about it. So there's actually a link on the top. There's a link at the top that says slides.app on Google. I recommend everyone to get on that. It lets you ask questions, and I can see them up here, so you don't have to like raise your hand, because that's kind of weird. And then you have to stop and everything. So type your questions on here if you have anything, make comments or whatever. I'll answer them, and it's just easier that way. So who am I? I am not working. Who am I? Mary Chang. I'm the project director for AIS. I basically just run all the workshops. I help coordinate my project coordinators for the workshops. I don't look like that anymore, but if you guys want to email me, my email is there. Reach out to me, want to talk or anything. Play games with Valerie. So everyone open this link. It's going to teach you to the workshop GitHub, intro.announcement.me. And the slides are going to be on there. There's going to be some Python notebooks. There's a README. For right now, don't open any of the open and collab links yet. We'll get that. We'll get to there. Just take notes. This is going to be more lecture-based than programming because machine learning has a lot of technical parts. So anyway, I'm going to give you guys like 5 more seconds. Just open this. The slides are on there. If I go too fast or go too slow, you'll go forward or stay back. So this is our agenda for today. What is deep learning? Why learn deep learning? Talk about data. We're going to talk about various Python libraries such as Numpy and pandas. And let's get started. So let's get started by taking a step back and asking ourselves, what is deep learning, right? Let's define deep learning in the context of intelligence, right? Artificial intelligence. So artificial intelligence, or intelligence in general, is the ability to process information such that it can be used to inform a future decision, right? That's what intelligence is. That's what you do whenever you learn from a professor, you use it so that you can answer your questions correctly in your exam, unlike me. So the field of artificial intelligence, or short, AI, is the science that focuses on building algorithms that can do exactly that, which is processing information so that you can inform future predictions. So put it short, artificial intelligence is creating algorithms that can make predictions. So machine learning, which you guys have probably all heard of, is a subset of artificial intelligence. And what it does is it focuses on teaching algorithms to learn from experiences without being explicitly programmed, right? So you've heard of training a machine learning model. What you do when you train a machine learning model is that it learns. It's learning how to make better predictions from the input that is given. And you're not explicitly coding that if you get an input of 1, you output 2. If you give an input of 2, you output 3. It's all learning by itself. So then we go even further. We go into deep learning. So deep learning takes this idea even further, and it's a subset of machine learning that focuses on using neural networks to automatically extract useful patterns in raw data. And then they use these patterns, features that they're officially called, to learn how to perform the task that's given. So this workshop is going to be teaching you how to prepare data so that we can put it into a deep learning model and then get output from it. We're going to do the second part that's all about theory and stuff like that. But we're going to go over about data processing and why data is so important to machine learning models today. So why deep learning and why now? Someone asked me about persimmons. I'll give you almost a month. You know any sort of recipes that involve persimmons. So if anyone came to Intro to Learning Python, I talked about my pure love for persimmons. Persimmon pie. I made it. It's banging. You try it. Anyway, so why deep learning? To understand why or how deep learning is different from machine learning, we have to learn about machine learning first, right? So traditionally, machine learning algorithms define a set of features in their data. So usually these features are handcrafted or hand-engineered, and as a result, they tend to be pretty brittle in practice when they're deployed, because obviously when you deploy things in the real world, the environment is not the same as what you trained it in. So this is where deep learning comes in. The key idea of deep learning is to learn these features directly from data in a hierarchical manner. That means you don't have to define any of the features beforehand or hand label them. So let's take, for example, face detection, right? So how does a program learn how to detect a face? So like we're talking about hierarchy, we have to break it down. So what a deep learning model first does, it goes to low-level features. Lines and edges, right? It just locates lines in your face, edges in your face, and then it forms and brings them into eyes, nose, and ears. It forms these edges of your contours of your face into these various parts. And then at the end, it finally puts it all together to form facial structure that allows it to determine whether it is a face or not. So this is the basis of deep learning, and all deep learning algorithms go through this process, where we break it down into a very subset problem, and we keep building upon it until we get to our bigger problem that we want to solve. This is a core thing to understand, so if anyone has questions, ask me. But yeah, so that's how faces are detected. It goes from the bottom up. So what are features? This is a big thing. So these are used to train machine learning, and be sure that distinct machine learning and deep learning. A lot of people use the words same interchangeably. They're not interchangeable. Machine learning doesn't include neural networks. They include things such as decision trees, random forests, and more concrete ways of, more set ways of creating classification or prediction problems. So for machine learning, we have to pass in data that is labeled. We have to hand label it. So if we had, let's say, we're trying to figure out if the difference between orange and alpha, we would have to go through thousands of columns of data, rows of data, and label each weight individually, each color individually, in order to pass it in to the machine learning model. This is where deep learning comes in, right? So let's take that to facial recognition. Back then, before deep learning and neural networks were the thing, you had to go in and label each line of your face by hand. You had to go in, take one picture of the face, draw lines, go to the next picture, draw lines of contours of the face, and it was extremely tedious. It was extremely horrible to have to do that by hand, and it would take a lot of manpower and a lot of time. So whenever deep learning came along, it allowed us to just give it a picture of a face, multiple pictures of a face, no labeling whatsoever, and we'd be able to figure out whether it was a face or not, just by us labeling it by whether it's a face or not, right? True or false, instead of having to manually draw all these lines and stuff like that. So let's talk about why deep learning is so big now. So if we can look at it, neural networks actually date back decades. Neural networks started in statistics. It's a field of statistics, not a field of computer science. And if we look, 1952, stochastic gradient descent. This is one of the first deep learning concepts, stochastic gradient descent. This allows us to optimize machine learning models, and we'll learn about this in the next thing because it's very calculus-based. But anyway, 1958, perceptrons, learnable weights. This is the beginning of a neural network. Perceptron is a neuron. 1986, back propagation. This allowed us to easier train and make machine learning, deep learning models learn faster, and it allowed us to introduce multiple layers. And then in 1995, we had our first deep convolutional neural network, which allowed us to recognize handwritten digits by just giving it digits and telling it what number it was. So why are we talking about all this now? Why is deep learning so big? So one of the first things is data. We have trillions of gigabytes that are getting passed each day everywhere, right? Let's see, we have like Netflix uses data, Facebook gathers data, right? Walmart gathers data. There's so much data in the world now that we can operate on and have collected that it allows us to create more complex models, but also more different models about everything that you can think of, right? Next thing is hardware, right? So let's talk about the new RTX 3090s, right? 3090, 3080, that whole series came out. It allows us to do faster matrix multiplication, allows us to run and train models faster, and then there's more specialized GPUs, right? Such as the A100, which was released. RTX Teslas, Quadros, if you've ever heard of those. These are all just GPUs that allow us to do matrix multiplication faster and allows us to train bigger and better models quicker and more efficiently. And parallelization is another big thing. Parallelization allows us to do multiple calculations at the same time instead of have to do them one by one. And then also the introduction of cluster computing. If you've ever heard of Hadoop, it's basically where you just have a bunch of computers together and they all just work on one problem, and just the amount of computing power that has increased in the past 20 years alone is truly amazing. So another thing is software. So back then, it was just math, right? You have to do everything on paper. In 1956, we didn't have computers to build machine learning models on, right? It was all statistical models. You had to do the math by hand. But now we have improved techniques. So just doing matrix multiplication, we've increased the speed of that, just multiplying numbers together. And we have new things such as new models, like object segmentation. We can do object detection, and all of this at a very high accuracy, right? 96% and higher. And then we also have toolboxes that makes these more accessible to everyone. If you ever heard of TensorFlow or PyTorch, these are Python libraries that you can use for your own things and build models, and you can build off whatever you want, and it just makes it more accessible for more people to use. And then these toolboxes also congregate the best knowledge at the time for people to use, so we're always working with the best. So one of the big things that we have to talk about with deep learning is data, right? You can't have deep learning without data. We have to talk about why data is important. Data is one of the fundamentals of deep learning. You can't have deep learning without data. So let's talk about a take about model-centric versus data-centric. I don't know if you guys heard of this, but we're going to talk about it, and model-centric and data-centric. So let's talk about both. So model-centric is a view where we focus on the machine learning model, right? We have to architect it perfectly to the data, and we have to make sure that's as efficient as possible. Well, that's what it used to be like in 2008, right? It's been how many years since 1956? We are at the best of the best we can be, right? We have already tried every single model that can exist. So we have to focus on the data. Our models are already as the best they can be. Basically, machine learning nowadays is just applying a previously made model on your data. So that's where data-centric comes in. Data-centric deep learning is a really big phase that's going on right now, and it's where we focus only on the data and not about the model. This is where you have to think about the way you collect data, the way you process the data, the way you represent the data, and all these things instead of focusing on the model, because we're already at a point where the model is so advanced that we can improve it on and further. So data, why is data important? It's food for your network. So it eats it up basically, and then it basically gives you what you want. So if you give it garbage data, it will give you garbage outputs. So it's very important to pre-process your data, and model performance depends on data. And then if you read the quote, what we call data are observations of real-world phenomena. Each piece of data provides a small window into a limited aspect of reality. Data is representative of our everyday lives, and with more data, we can fully represent our environment. So, data preparation. This is one of the most tedious part that everyone hates. You have to look at CSVs and you have to process it and all that stuff, right? You can't just make real models. But raw data has to be prepared in order to be put into your deep learning model. So this is what we're going to learn today, and we're going to be focusing mostly on it because it's a very important concept, and it's also kind of hard to grasp before going into theory of deep learning. So here are the main concepts that we're going to talk about today. Handling null values, standardization of data, categorical values, and Onehot encoding. So let's start off with handling null values. Life is never perfect. You're not always going to get perfect data. You're not going to get a value for every column that you have in your data, right? So we have to either remove them or use imputation. Imputation I'll talk about in a bit. But most of the time, we just remove them, right? So for example, let's take we have the colors of a shirt and the price of a shirt. So we can see that we have a white shirt, blue shirt, red shirt. We can see for one of the blue shirts, we have nan as the number for price. So what does nan mean? It means not a number. That's what it's short for. And it means that a value doesn't exist, or in other words, it's null. So if we do df.drop na, df you'll learn about later, it's called data frame. Basically what it does is it stores data sets. And drop na means drop not available, or in this case, non-number. So basically this delete that row. And then the right would be the output, and we just wouldn't have to do it. So what are some implications of this and why we wouldn't want to do this, right? If we had a data set with only four things, right? If we remove one, we just remove 25% of our data set. 25% of the data is just gone, right? So a way that we can counteract this is called imputation. Imputation is the process of substituting the missing values. If you look at your slides, it's easier to see the code. You can see from sklearn, which is another machine learning library, we import a simple computer, and then we we initialize it into the computer, and then we give it missing values equal empty demand. So that means that's the values it's going to replace. And then we can see the strategy. There's various different strategies that you can use, right? Try to think of something on your own to replace values, because we can't just replace them all with zeros or ones or thousands or whatever like that, right? Because that would greatly affect the data. So the strategy we have is mean. So what we do is we actually replace non-numbers with the mean of the data set, which allows us to lessly affect the data and focus it more on the mean. Although if you think about it statistically, this would put more weight on the mean of the data set, which would skew it in a way. Okay, so now we have normalization. This is another process that transforms values such that the values scale from 0 to 1. So this is the formula. We take the number that we want to transform minus the minimum number in the whole data set, divided by the maximum number in the whole data set minus the minimum number of the whole data set. What does this do? It basically transforms each value from whatever it is to a range from 0 to 1. So why do we want to do this? The reason is because imagine if you had age and weight, right? Honestly, your weight is going to be a higher number than age, right? So like I'm 20 and I weigh like 170, 180. So obviously 180 is bigger than 20, right? So what that would do is that when you put it in the machine learning model, it would put more weight on our weight and less on our age. So we have to make them go to the same scale so that it equally puts weight and is equally judged within the machine learning model. So if we see here, we can see that we have the white shirt, blue shirt, and red shirt, and then they all are prices above the value of 1. And then if we put it through the formula, it normalizes them, and then it moves them all in the range from 0 to 1. As you can see, blue is 1 because it's the max number, and you can see red is 0 because it's the middle number, and white is around the middle because the middle would be the mean. So let's talk about handling categorical variables. So categorical variables are, like it said, not numerical. These are things such as shirt sizes, medium, large, extra large, or colors, blue, green, or anything else like types of loans, types of cars, anything that's basically a word and not a numerical value. So we have two types. We have ordinal categorical values, variables. What that is they're variables that are go in an order. So we can see that large is bigger than medium and extra large is bigger than large, right? And we have nominal categorical values. Nominal categorical variables are basically variables that don't have any distinction between each other, right? Blue is not bigger, less than a green, and vice versa, right? Blue and green are just colors. So we have to take this in mind because we have to process them differently, because one is dependent on the other while the other isn't. So how do we do this? Let's start off with handling ordinal categorical values. So we basically just replace the corresponding, we replace the categories with the corresponding nature. And this allows the model to build relationships. So the reason why we have to process them differently, right, is because in ordinal categorical values like medium, large, extra large, right, there's relationships between the values. And in order to preserve that relationship, but also convert it into a format that a machine learning model can process, we have to map it like this, where we replace all the mediums with 1, larges with 2, and for example, extra larges with 3, right? That shows a relationship in that medium is the smallest, large is the next biggest, and then extra large is the biggest. We're maintaining that relationship while also processing the text into a format that we can do without using a machine learning model. So why can't we do this with a categorical variable, right? So let's take, for example, we color map 0 to white, 1 to blue, and 2 to red, right? If we look at the conversion, it does it, right? But if we think about it, there's no relationship between white, blue, and red, right? But by classifying them as 0, 1, and 2, our machine learning model will think there is a relationship that doesn't exist, and will think that white is the least, blue is the next biggest, and then red is the largest, putting a large weight on red with least weight on white. That's not what we want. So we have to do something called Onehot encoding. What is Onehot encoding? It basically creates n columns where n is the number of unique values that the nominal variable can take. So what does that even mean? if we take a look at the table, we can see white, blue, and red, and then we convert it by adding 3 extra columns, and then we put a 1 in what it is. So we can see we have the color blue, color white, color red, so it will have 1 in one of those columns. The reason why we do this is because then the machine learning model won't think there's a relationship when there isn't. And it also lets us convert the words to numbers because machines can't read, right? Computers can't read. We have to convert to numbers so that we can do math. All neural networks are in deep learning is just math. It's just multiplication, division, subtraction, addition, and some fancy calculus, but that's beside the point. And then if we can see that the x-min is 10.23, x-max is 49.28, and then if we plug it all in the formula, it would output the values on the right that are normalized. So we learned all of that. We learned the concepts. Now, what do we do with them? How do we execute on them? We have to use a library called Numpy. What is Numpy? It's short for Numerical Python. It's an array library that lets us create arrays and use them in various ways that we can't use Python lists for. And this is how you import it. Import Numpy as NP. It will always be called NP, so make sure you import it that way. People will be confused if you use the plain old Numpy. So, crash course of lists. Lists work like this. Indexing starts at 0, right? And then it goes to n-1 because it's 0 index. And then negative indices count from the end of the list to the beginning. So if you have -1, that accesses the last element of the list, and so on and so forth. So now we're going to talk about list slicing. So the basic syntax is that we have the start, the end, and the step. Most of the time, we just do start and the end, and the step will automatically be set to 1. So if we see from 0 to 5, that will collect the elements 0, 1, 2, 3, 4, not including the fifth element. And then we see 5 to 8, that collects 5, 6, and 7, but not including 8. It's inclusive at start and then non-inclusive at stop. And step is always defaulted to. So, matrices. How do we represent matrices in Python, right? We can't just create a matrix data type. So what we have to do is call it a list of lists. So if we see a matrix on the right, we can see that it's represented on the, matrix on the left, we can see that's represented on the right by 3 lists within a list, also called an LOL, list, right? To extract an item, we have to do matrix, row, and column. So if we wanted to get the number 1, we would do matrix, square bracket, the row we want, so it's in the 0th row, right? So that would give us the list 0, 1, 2, and then we have to access the element within inside that, and that column index would be 1, so that would give us the number 1. To get a whole row, matrix row is the answer, so if we want to get the second row, we would just do matrix 1. Basically, you're accessing the list, and then another list. This is a really important concept that you have to get your head around, which we have exercises for. And to extract the column, so if we want to extract the vertical column, the thing is that you can't do that in normal Python. So this is where Numpy comes in. List and lists don't work like matrices, right? We can't extract columns, and lists can contain arbitrary objects, right? Because matrices all contain the same object, whether they be decimal or integers, they can be mixed and matched. And list elements are also scattered in memory. Unlike matrices implemented in Numpy, arrays contain all the objects right next to each other. So we're going to talk about the ND array. This is the array that's introduced by Numpy. It's multi-dimensional, homogeneous. It's a homogeneous array of precise items. Basically, what that means is that it's a matrix. So indexing is the same as indexing and slicing when we have a 1D array is the same as a Python list. When we're indexing and slicing a higher dimension, for example, in a matrix, we can see that it uses a different notation where the commas would be separated in dimensions. So for this one, we do -3, which would go back 3, and then 2, so that'd be going up and down 2. So that's how we get 21. In this case, whenever we have a colon by itself, it goes from 0 to the end of that colon. As you can see, the first one is the number of rows that we want to go down. So we can see that we select the first 3 rows, and then the next one is the number of columns we want to select, which is 0 to 5. So we can see that's 0, 1, 2, 3, 4. And then same thing for this. Whenever you have a blank colon, that basically selects everything within that dimension. I know I'm going through this kind of fast because I want you guys to work on that exercise because this is one of the most important things to get your head around is slicing. We're going to have a bunch of exercises over it that we're going to do in a couple of minutes. So make sure you have the slides put up so you can refer back to this and do them. So from this one, we can see 1 and then 3 to 6. So we can see that it chooses from the first column, first row, which is the second line, from elements 3 to 6. So it selects 11, 12, 13. And then we can see this. We can see that it's blank, but then there's a third argument, that's the step. So it steps by 3 for the row traversal, and then for column traversal, it steps by. So we kind of sped around through that, but it's only because I want you guys to take a look at this. So make sure everyone, if you have a laptop, or just work with your buds, looking at you, go on this website. There should be a thing called, there's a thing called Numpy exercises. It's under the word exercises. If you click open and collab, I would like you guys to do like the first 10 of those problems, right? I'd like you guys to open that and do the first 10 of the problems. And then we're going to take a short little break while you guys do that. I'm going to be walking around. Ask me if you need any help. But here is the member attendance. If you're a registered member of AIS, this is attendance. Take the QR code or go to the link and the link code is 1484. So let's take 10 minutes. Make sure your intro is announcement on me. Go on the collab notebook and then do some of the exercises because slicing is very important to know when you're working with data. Including the online people, you can access this too. You can work with your partners or whatever. Does this work? Can I do this? Oh. So just take 10 minutes, go through some of the exercises. If you have any questions, raise your hand, I'll go to you. And let me see it. Make sure, look over this slide for any questions. I'm here. And then after this, we're going to be talking about pandas, which is data, loading data sets and manipulating the data sets. So, if you go into GitHub, there's 2 files. There's one called Numpy exercises hints. If you want hints, there's hints there. There's also one called Numpy exercises solutions. So if you want solutions, you can go there if you're kind of stuck. So someone said, Luke Lay said, is normalization flexible? And let's say that the expected age of humans were 100, and then someone were to come along with the age of 101, thereby changing their max value. So it is flexible in that because basically what it does is it's quantifying within the whole data set, right? So this is really statistics-based question, but for Luke, is he in person? Is Luke here? Luke. So it's a statistics-based answer in that by adding an extra thing, it shifts everything, right? That's what it's called normalizing, right? Have you ever heard of a normal curve? Yeah, so in a normal curve, everything fits within that curve, right? So even if you added another thing to the data set, you would form the curve so that it fits the data set, right? So the reason why we do normalization is that it correctly represents that it is in a normal curve. There's another thing called standardization, which does it from -1 to 1, right? That's based on the standard deviation. That's based more for Gaussian distributions. Like if you want to read into it, Gaussian distributions. Normalization is more for non-Gaussian distributions, which is most data. What? Okay.
I'm gonna try it out.
I have it as a PDF on the GitHub.
You what?
Like on the GitHub as a PDF.
Oh.
Like just in case.
Oh, it's there?
Yeah. The slides are on the GitHub that you can access in this link. It's a PDF. It's like all like introductions to learning. Yeah. Slicing is very important. Working with Numpy arrays is very important. Understanding dimensionality is really important because there's going to be a lot of times where you're working with tensors that there's no tensor flow. There's a wrong dimension. I get confused if you don't understand the basics of multi-dimensional arrays.
Like the AIS Workshop of Python.
What? Are red pens pandas? I thought they were pandas. They look like red pandas. Why are they called red pandas then if they're not pandas? Oh, you guys didn't know? Yes, for this, you don't know the way it works. What do you got? Oh, okay. So, you go back here. So this is like a notebook, right? So it's like a short Python thing. Okay, so it lets you run this, and this is basically just a computer that's teaching you everything, machine learning, whatever. Everything's already installed, right? But for our purposes, it's just a So you can just type things in here, these little things, right? Yeah, so run it. Yeah, so in Python there's actually no semicolons. Yeah, there's no semicolons. There's also no brackets either. The way you write it. So we ran, so we imported it. So now you can do like three proper size, right? So obviously this is really confusing if you've never seen writing for it. So I would just put it here and then just lowercase it forever. So it's yeah, right. So it's great. No, so it's like more like C out. Yeah, so it just prints it and then you can see it. And then there's also this really cool thing in notebooks. This is only is that you can just cover everything. So that's something you can do only in notebooks. Yeah. So if you want to print out like a variable, but like you can do print X, right? But in notebooks, it's X. Oh. So it's just a piece of life. Yeah. First side again. So the way our membership works is that we open it once a semester. So the next time it opens is next semester. So you're gonna have to answer next semester, right? But it's kind of like
Yeah.
All right, 5 seconds before we go on to the next part. If you guys have any questions. Yeah. It's all good. Yeah, so right now, this is what you see. Yeah, this is all the okay, yeah. Yeah, so it's more about the so I was just with this, and then obviously this, and then there's solutions. All so you're not doing all of it. Oh, okay, yeah. All right, so there's 100 exercises. The end ones are kind of really hard. So there's solution ring in the thing, the end.md file. Make sure you take a look at that. Everything's in the GitHub repo. Take a look at everything, click on everything, make sure you can see all of it. To open the notebooks, make sure you scroll down and click Open Collab. The ones that are labeled like Intro to Python Pandas and Intro to Numpy and Python Task Force, I basically just made a notebook and I explain everything. Those are really nice to go through. Please go through them. I spent so much of my time and tears and blood and effort. So I'd be kind of sad if you don't use them. Okay, but we're gonna continue on. We're gonna continue on onto pandas. was recently brought to my knowledge that red pandas may not be pandas, and I'm going to be surprised by that fact. But in my heart, they are pandas. So there's a little cute red panda, just for funsies. But anyway, what is pandas? If you ever go into machine learning, do any kind of deep learning project, you will always use pandas. Pandas is one of the most widely used Python libraries in data science. It allows you to create a data frame object. So while NumPy lets you create a NumPy array, pandas lets you create a pandas data frame. So what is the data frame? It's like a spreadsheet with column names and row labels. It's basically just a huge table that's accessible within Python. And why is this important? It's important because all data, or most of the data you'll be encountering, is in a CSV file, also known as an Excel spreadsheet. So while it might seem kind of dumb that way, that you're getting an Excel spreadsheet, it's because CSV stands for comma separated values. What that means is that every value is separated by comma. If you open an Excel spreadsheet in text editor, you can see that yourself. But you will be working with CSVs throughout your whole entire machine learning, deep learning career. So that's why we have to learn about pandas. It's imported like that. Import pandas as PD. Memorize the acronyms because this is the general accepted short way to spell it. Pandas as PD and NumPy as NP. So how do we load data? We read CSV into DF, which is short for data frame, and that's also common terminology too. Make sure you remember that. DF stands for data frame. This we use all over the place. We do pd.read_CSV, and then in implications, the path of the CSV file. This basically converts your CSV file into a data frame. And this is very important. You will always use. Always. So, viewing data. Also, this is a very short overview. If you go into Intro to Pandas, I go into so much stuff in there. There's so much information. Please check it out. It is so useful. Not only because I spent like 20 hours making it, but because it's actually useful. Anyway, to view the data, you can use the column name. You can use columns, df.columns, or you can use df.index. df.index is not as commonly used. But to view all the columns, you can do df.columns, and outputs the type of objects. Selecting data. So like a map in Python, if you've ever heard of that, but if you haven't looked it up, you select values by key, which in pandas is the column label. So in this case, to access the column called A, we would just do df square bracket, quotation A, quotation square bracket. That would give us the whole column of A. And that's basically it, because I want you guys to read the short little notebook that I made. It's way easier when you can do it by person. So that's basically it for the workshop. It's kind of short because I want you guys to work on the exercises and then just ask questions. That's why I'm here, to ask questions, right? And the only way to learn is just by doing. So you guys are all free to go. But if you want to stay after and work on exercises, I'm going to be here until 6:30. That's it. Thank you everyone online for coming. Please email me if you have any messages.